the real holistic solution to managing indoor air quality. Whether in a residential, commercial, industrial, or institutional environment, the solutions are the same and effective to reduce microbials, particulates, and other contaminants that pollute our indoor breathing space. Several years ago, Normie.org started a national survey asking homeowners in particular to rank their indoor air quality from 1 to 10, 1 being poor, 10 being excellent. And so the question, how would you rate the indoor air quality in your home? Now, with several thousand responses, the evidence is clear that most people, in excess of 90%, rank their indoor air quality at a 7 or below. That many people recognize that they have a problem, but not quite sure what that problem is or who to call to resolve it. This short course should help put those concerns to rest by suggesting the sources of the problem and the solutions that are effective in improving indoor air quality in virtually every single case. We are not unaware of the problems in our homes and offices. Many people react to the contaminants that exist in our indoor environments, and there is even an entire segment of the medical industry that now recognizes and treats the symptoms of environmental illness. The AAEM, American Association of Environmental Medicine, has been a leader among doctors in training and helping them resolve the problems that people experience as a result of indoor air pollution. No longer are those affected shuffled off to a psychiatrist or disregarded as a hypochondriac, because more and more evidence is coming to light every year on the devastating effects of long-term, low-level pollutants on our health and general well-being. Allergy, lethargy, overall unproductivity are now being associated with many of these contaminants, and property owners, managers, and doctors are interested in finding solutions. This class allows you to take a giant leap toward a holistic approach to dealing with indoor air pollution. But first, you must understand what comprises or makes up the contaminants that we breathe every day indoors. You could classify every single component that affects indoor air quality into one of these 7 components. And if you know what the problem is, the solution is easier to understand. As I've said many times, prognosis without diagnosis is malpractice, and so it is with indoor air pollution. If you don't understand the problem, then you don't have a solution. If you do understand the problem, and you understand that it's multifaceted, then you will understand that the solution must then be multi-strategic. There is no one-size-fits-all, or just put this machine in your house and all will be well approach to solving these issues. It's about dealing with all of them in a synergistic way. So let's talk about each of these as we see them in our environments and as they pollute those environments. Particles. That's a dust mite. 32,000 of them on an ounce of dust. And there are a lot of people who are allergic to dust mites because dust mites love to eat organic material, dead skin. And when they eat that dead skin, they do what other animals do, and that becomes aerosolated. And that dust mite feces has enzymes in it that makes people allergic to it. And so dust mites obviously are a problem, and what they do after they eat becomes a problem. But there are other things in the environment floating around as well, pollen and mold spores, particulates that need to be taken out of the air that we breathe. There have been multiple studies about submicron particles and how they actually get past our natural filtering systems, the nose hairs, the hairs in our lungs, and actually can even be brought into our bloodstream. And so dealing with particles, of course, is an extremely important way of dealing with indoor air quality. Unfortunately, in the indoor air quality business for the last few years, so much emphasis and focus has been put on particles that some of the other problems that are in the environment have been ignored. And so a lot of effort has been made to make really good and efficient filters. But that's only one solution to one specific problem. Odors. In our environment, we have odors, all kinds of odors. Sometimes those odors are symptomatic of gases. Sometimes they're symptomatic of other things like cooking odors or secondhand smoke. But odors are a tremendous allergen, and it's an indoor air quality issue that needs to be addressed. Gases. Of course, I tell people in our indoor air quality classes that we have enough chemicals under our kitchen sink to kill a couple of elephants. But the truth is that we have all kinds of things in our environments that are off-gassing different types of chemicals. If you think about walking into a room that's just been painted, that room smells. There's your odors. But those odors are actually coming from gases from the paints and the VOCs. Those gases will continue for years and years, sometimes up to 10 years, after the smell of the new paint has gone away. Formaldehyde, glues, OSB, carpeting, all of these things put off gases. Some of them we smell, some of them we don't smell. Usually at this point when I'm talking about indoor air quality, I talk about these three as they're really evidenced by secondhand smoke. A single cigarette produces over 4,000 chemical gases, 43 of which are carcinogenic. And in most cases, when they try to take cigarette smoke out of an environment, like in a bar or a restaurant, they use a filter, and so they're successful at taking the particles out, but it still smells like an ashtray. And that's because they haven't removed the gases and the odors that remain. So if you were going to have a multi-strategic solution to secondhand smoke, you'd have to have something that would deal with not only the particulates, but also deal with the gases and with the odors. And then of course we have biopollutants, and we think about mold because it's something that's very obvious and there's been a lot of press about it, but there's all kinds of biopollutants in our environments. E. coli, salmonella, methicillin-resistant Staphylococcus aureus, MRSA, all kinds of things going on in our environments that actually become aeroslated. Now that's not because the bacteria has wings and can fly around, but it does in fact travel on the dead skin cells and other things that are floating around in our environment. When I talked about particulates, one of the things that I didn't really mention but is one of the biggest pollutions in our environment is our cells. We actually put off dead skin cells. And if you look at a shaft of light in the morning and you see all of those things floating around, 80% of that, according to scientists, 80% of that is dead skin. Well, that dead skin becomes a little magic carpet ride for bacteria and for viruses and other types of biopollutants. And so biopollutants are a major issue not only on surfaces but also when they become aerosolated. That's the fourth component of indoor air quality that needs to be addressed. Temperature and humidity. Obviously, as the temperature gets high and the humidity gets high, much greater chance of mold growing. Even when the temperature gets low and the humidity gets low, there's a good possibility that bacteria will grow. And so one of the things that we do in our trainings is we talk about trying to keep the relative humidity between 40 and 60% so that there's a less possibility that contaminants will actually grow in that environment. But these two components obviously need to be addressed. In the air conditioning industry, they talk about combining these two, and they deal with what's called psychrometrics and how the two actually work in environments to keep air cleaner and how they can make the air conditioning systems more efficient. Temperature and humidity. And then the seventh component is comfort, and that's how air moves in the environment. You know, when you're in an environment that's got stagnant air, where it's hot at your head and it's cold at your feet, it's extremely uncomfortable. By getting the air moving, by using ceiling fans, leaving the air conditioning system on, so that it's actually moving the air, not only are you keeping a more comfortable environment, you're taking away the false positives that a thermostat might give you false readings that you might have about the heat or the coolness of that particular environment. And if you're using proactive air purification technologies or passive technologies, as we're going to talk about in just a few moments, moving the air is vital to keeping good air quality. By moving the air, you're trapping the particulates, you're taking the proactive air purification to the surfaces, cleaning the bacteria, killing the mold, you're dealing with odors and VOCs. All of that has to do with air movement. So these 7 components, and again, we're talking about particulates, odors, gases, temperature, humidity, and comfort. All of these have to be addressed if you're going to have a multi-strategic solution to this multifaceted problem. Particles, biopollutants, odors, temperature, humidity, gases, and comfort. You need to address all of them. So the first conclusion that should be drawn after understanding the many facets of the problem is that solution is not just about filters. Filters play a very big part in resolving many issues, but they certainly don't address many of the pollutants like odors and gases, and they are restricted by the difficulty of trying to get some of these pollutants to the filter. We'll talk about the value of good filters and the shortcomings of bad ones shortly, but even before that discussion, it's clear that it's not the whole answer to IAQ management. It's not about source removal. If we are producing much of the dead skin that's in any environment, removing us is not the answer. Yes, we can give our cat to Aunt Sally and tell our wife to smoke outdoors, but there are so many things in our environments that simply cannot be removed. After all, who wants to live in a stainless steel house? So many of our construction materials are great feeding ground for mold and bacteria, and how do we fix that problem? And it's not about dilution. Certainly adding fresh air into the home or office is a good way to dilute some of the contaminants, but as I suggested earlier, in some parts of the country, the last thing I want to do is bring so-called fresh air into the environment. At least I wouldn't want to bring it in without it having been cooled, filtered, and purified. Again, certainly a part of the solution, but not the entire solution. Our solution, the Normie approved solution, is a multi-strategic approach with these 3 prongs: air filtration and purification, surface protection, and lifestyle changes. When I wrote my book, Mold-Free Construction, and that's available at moldfreeconstruction.com, I suggested a sanitization protocol, and it incorporates this 3-pronged approach. Take a look here at a recent table that I found that suggested the top 10 solutions to indoor air quality issues. It's interesting because the 3-pronged approach is included right here. You've got utilize air purification, utilize air filtration, dehumidify or humidify, reduce carpeting, revise your cleaning schedule, use hypoallergenic bedding, use green cleaning supplies, reduce volatile organic compounds, respond quickly to leaks or moisture, manage plants, and clean your pets. It's interesting that this 3-pronged approach is included. Lifestyle changes that include decluttering, scheduled maintenance, and so forth is incorporated in the revised cleaning schedule. Respond quickly to leaks and use hypoallergenic bedding. Using green cleaning supplies that are low in VOCs deals with surface protection, and I have many more listed in my sanitization protocol. So we want to now close in on air filtration and purification technologies, which is probably the most technical of all the solutions. There are so many air purification technologies and so much marketing hype that it's often difficult to understand exactly what works and what doesn't. So let's simplify the approach. Every piece of air purification equipment in the market today is either active or passive in its approach to resolving indoor air pollution problems. By passive, we mean that, like a mousetrap. It's bringing the pollution to the solution. A filter is a good example of a passive technology because the filter sits there waiting for the air to be brought to the filter. The other option to take care of that pesky mouse would be to buy a cat. That cat is on seek and destroy mode, and she's going out there to take the solution to the pollution. That's a proactive approach to solving the problem. So in that context, let's talk about the different technologies in the marketplace and talk about each, how they work, and the advantages or disadvantages of each. What you'll quickly see is that a synergistic approach utilizing multiple technologies in a combination of passive and active is by far the best and most effective way to deal with all of the potential contaminants in the indoor environment. To take this a step further in evaluating technologies on the market today, all of them, that is all of the equipment on the market today, utilizes one of 5 technologies: either filtration, ionization, ozonation, ultraviolet, or ultraviolet with target plate. The very best equipment utilizes several of these, as you'll see in a few moments, but we must first understand the value and limitation of each before we have a clear understanding of the efficiency and effectiveness when these are combined. Filters would include all of the different media that we see in the market. They might be fiberglass, foam rubber, carbon or carbon impregnated, polyester, but each serves a different purpose based on its density and configuration. HEPA, high efficiency particulate arrestor, filters, probably the highest quality filter on the market today, incorporated a pleated configuration and is usually appropriate only in commercial environments where the air handlers can handle the tight density of the filter media. For the average consumer, anything above a MERV 7 or 8 rating, according to ASHRAE. Now, ASHRAE is the American Society of Heating, Refrigerating, and Air Conditioning Engineers, could negatively impact the efficiency of the air conditioning system and even, in many cases, damage blower motors and other moving parts of the system. MERV, which is the Minimum Efficiency Reporting Value, a standard set by ASHRAE to determine the effectiveness and efficiency of a specific media. Ionization sends an electrical charge into the environment using several different types of components to charge particles and make them flock together or aggregate so they can be carried to the filter. In many cases, submicron particles are so light that they are never brought to the filter, and these are, by most studies, the most harmful to our health. Bypassing the natural filters of our nose and lungs, these particles can wreak havoc on our health. Ozonation is produced by a couple of different methods. Ozone can be very effective in reducing microbial pollutants in the air and on surfaces, but it must be closely monitored and is problematic for a small percentage of the population. Ozone production is regulated by some states, and in particular, the state of California bans air purification technologies that incorporate ozone production in their machines. Fortunately, there are now other technologies that are just as effective without the harmful side effects. Ultraviolet has been widely used in the air conditioning industry, but unfortunately it seems as though many technicians really don't understand how it works, or doesn't, and so many have lost faith in the effectiveness as an air purification technique. With the advent of target plates, the photocatalytic oxidation technology is one of the newest technologies addressing airflow and has proven to be extremely effective in keeping air and surfaces clean of many contaminants. Let's talk about each of these in a little more detail and discuss whether they are active or passive in their approach to air purification. This is a good example of a traditional pleated filter. There are some limitations that inhibit the effectiveness of filters, and much of that has to do with the type of filter that's used and the maintenance, or lack of it, that's required. We've talked about the variety of filter media that can be used, but all filters are limited by the air handler itself in terms of the amount of air that actually gets to the filter. Air exchanges are a way of describing the effectiveness of the filter, but it ignores the reality that much of the air in any environment never actually gets to the filter. Just like the swirling leaf in a swimming pool that never gets to the pool filter, the air in any environment has pockets of air that never move. At least that air never gets exchanged and therefore is never really filtered. Maintenance is probably one of the biggest issues with filters because people often will leave their filters in for a very long time. So long that the media is so full that it actually sucks the cardboard frame of the filter away from the edges of the return, causing blow-by. And again, the air is not filtered. If filters are not changed regularly, they can become a media for mold and bacterial growth, a syndrome that we in the industry call bionesting. The solution is a good MERV 7 or 8 filter, frameless, impregnated with a good antimicrobial. And if you view Best Living Systems module at the end of this module, also attached to this lesson, you'll see the value and efficiency of the Perfect Fit filter for most 1-inch applications. With all this understood, the filter is still passive, waiting for the contaminants to get to it. We highly recommend a good filter, but it should be only one of the parts of the solution. And it should be one that doesn't cause the very problems that you're trying to solve. Ions are invisible particles, either molecules or atoms, which bear an electric charge. Atoms, for instance, consist of an atomic nucleus that contains neutral neutrons and positively charged protons, as well as orbiting electrons that are negatively charged. And when an atom is in neutral condition, the number of protons and electrons, which are negative, protons positive, electrons negative, is equal. When the number of protons and electrons is not the same, the particle becomes an ion that is either positively or negatively charged. Negative ions can be artificially generated by electrical devices such as ionizers, which use an external power source to generate large quantities of negative ions. Virtually all particles in the air have a positive charge, while negative ions have a negative charge, in which case negative ions and particles magnetically attract to one another. When there's a high enough concentration of negative ions in the air, they will attract to floating particles in large numbers. This causes the particle to become too heavy to remain airborne, and as a result, the particle will fall out of the air and will then be collected by normal cleaning activities such as vacuuming or dusting or even in the filter. The ionization process has been used for years on the construction sites and other locations where particulates need to be removed from our breathing space. Negative needlepoint and pulsating ionization simply charge those particles that are then attracted to one another and either dropped out of our breathing range or taken to a filter. The newest ionization technology is the dielectric barrier ionizer. This component actually creates what some call a bipolar ion or clustered ion, where both positive and negative ions are combined in the same charge. This sounds counterintuitive, but testing has shown that this actually happens and that the clustered ion, though safe for humans, is lethal to microorganisms like bacteria, viruses, and mold or fungus. This is a completely natural process, utilizes low voltage, so it's an energy-saving process, and effective on a variety of IAQ contaminants. When combined with other components, this technology produces a powerful oxidation process, and Best Living Systems trademarked it as multi-cluster ionization, MCI. It's just a better way to address many of the contaminants in the indoor environment because it produces very low levels of ozone, nearly immeasurable and safe. Best part of all, this technology is proactive. It sends the solution downstream to the pollution and will therefore help keep air and surfaces clean, even quite a distance from the equipment. There has been much concern about ozone, and I just have to say that much of it is inaccurate. Though there is no need now with the newer technologies to incorporate ozone in the air purification technologies, the production of ozone is as natural as lightning and actually causes the clean, crisp smell that we get after a thunderstorm or at the beach or in the mountains. Called nature's cleaning product, ozone can be a very powerful oxidizer and when used correctly can be very effective. Though highly efficient for smoke cleanup and fire restoration projects, more IAQ professionals steer customers away from the use of ozone, even at low levels, due to the sensitivity of young children, the elderly, and immunosuppressed people. I'm thankful that there are technologies that have advanced beyond our need for a discussion about the value or limitation of this specifically proactive technology. This brings us to ultraviolet lamps, the darling of the HVAC industry. It's long been known that UV light at the germicidal wavelength, 254 nanometer, is extremely effective against microbials. The food processing industry, the post office, and other applications have been fully convinced of its effectiveness and utilized it for really tough organisms like E. coli, anthrax, to name a few. Unfortunately, in the air conditioning system, the limitations of the technology enable it to be very effective in cleaning the surfaces on the inside of the air handler, but not very effective in sending any of that cleansing power downstream into the airflow. Why? Well, the UV technology has two major limitations: time and proximity. How long is the microorganism exposed to the light, and how close is it to the light? In most cases, air conditioning contractors have found that due to the high rate of speed with the air racing past the UV light, that the bugs hardly get a sunburn. Ultraviolet light is great for the surfaces inside the system, but not very effective in the air stream. It really is a passive technology, waiting for the bugs to come close to it so it can zap them, change their DNA, or neutralize them. Over the past few years, scientists and engineers have learned the power of a combination of UV, the germicidal wavelength UV, and a target plate. This UV becomes a catalyst for producing a much more powerful oxidizer than actually does get into the airstream, clean the air and surfaces downstream from the air handler. When combining these two, the UV and the target plate can then be coated with multiple coatings of different metals, its shape altered to expose more of the surface to the UV, and in turn produce a powerful clustered ion similar to the dielectric barrier ionizer we discussed earlier. This proactive technology is becoming the choice for all air purification technologies, and when combined with other components, as we'll discuss in a moment, air purification technology has now taken a turn toward becoming the foundation for creating clean, healthy environments indoors. No longer is this technology an option, but a must for anyone who's interested in addressing all the pollutants now found in indoor environments. This concludes our training on IAQ technologies. IAQ Basics 101. Remember that the combination of many components into a single product is the very best way to address all of the contaminants in any environment. You've got a multifaceted problem, you need a multi-strategic solution. If you have a greater interest in the products that have been developed around the clustered ion, multi-cluster ionization trademark, we have provided a module on your page entitled BLS Products to help you better understand the options you may have for your own use or may want to offer to your clients. The trademarked MCI multi-cluster ionization technology are incorporated in all of these products, from HVAC probes to standalones. They're affordable, effective, and efficacious for air and surfaces in virtually any environment. Safe for humans, but lethal to microbes. Thank you for taking the time to get better educated on the basics of IAQ. We offer more advanced trainings in the IAQ field, which includes specific trainings on mold, formaldehyde, as well as more trainings in the indoor air quality field itself. And we look forward to providing more information in the classes ahead.